In this section, we learn another technique of integration. This technique is called integration by parts. In this method, we are given some function and we want to integrate it. And to do that, we need to, or in order to apply this method, we apply this idea. We split the function into two parts. One part is easier to integrate. The dv is easier to integrate. The part that's easier to integrate, and this part u, we differentiate it. So the integral here will be given by u times v. V is the integral of dv minus the integral of v du. So this is the rule that we're going to use in this section. So what do we mean by u, dv, and how to choose them? Now, integration by parts is a technique that's used to find integrals for some class of functions, and these functions can look like this. For example, x e to the x dx. As we can see here, we have two integrand that consists of two different classes of functions. X is algebraic function, x squared, x minus 5. All these polynomials can be are called algebraic functions, and e to the x is called exponential function. And those are two completely different functions. So we have, if you remember from previous section, when we learned something about integration by substitution, we said that it's very important to find some relationship between the parts of the function. I mean, the relationship should be as follows. One of them should be an original function, and the other part is the derivative of that function or part of the derivative of that function. But here we have two completely different functions, x e to the x. Also, we may have x natural log of x, or x minus 1 times natural log of x, or something like that. Also, we may see in other courses x cosine x dx, x sine x dx. But in this course, we don't deal with trig functions. So these functions can be integrated using integration by parts. So we need to choose u and dv. So which part is u and which part is dv? Dv is the part that's easier to integrate. For example, we have x and e to the x. If they are equal, we don't need to worry about which one to use for dv. So here we can use e for dv, we call this dv, and x, we call it u. For this function here, if we use if we use dv for natural log, then we need to integrate this to find v in this formula. So how to integrate natural log of n? It's not easy to do that. We need to apply some formula, but that's out of scope of this course. So in this case, we don't need to integrate ln x, but we can differentiate. If we let ln x be u and x is dv, then this becomes easier because we want to differentiate u. What is derivative of natural log of x? It's 1 over x. So this is very easy. So we choose dv depending on whether it's which part is easier to integrate. And then after choosing that part, the other part will be u. There's actually some students confused of what they should use for dv. Sometimes they feel lost with different types of functions. So there's some word that's used to determine the priority for the substitution u, and I'm gonna write the letters that we are interested in this section. So LTE, L for logarithmic. Let's instead of T put A, LAE. A is algebraic, and E is the first letter of exponential functions. So in this section we deal with these three classes of functions. So the priority is in this direction for U. So if we see logarithmic and algebraic, we need to use U equals L, the logarithmic, and dV is the algebraic. If we have algebraic and exponential, as we can see here we have algebraic and exponential. So we let U equals the algebraic because algebraic appeared first and then exponential. So the priority for U is for x. So U is x, and then dV is e to the x. Okay, and after doing that, we start some process. I'll show you by solving some problems. So let's solve the problems that we already have here, or the examples that we already have. So the first example was evaluate the integral x e to the x dx. Now here we have algebraic and exponential function, and according to this rule we see that the exponential is appeared in the at the end of this word, and the a appeared before exponential. That means a is u, or algebraic function. U is the algebraic function, and the other part is dv. After determining this, we write u equals x, and then find the derivative of this. Derivative of the derivative of u is dx, and then dv is e to the x dx, and we integrate this. What is the integral of e to the x? Is just e to the x, and then we multiply this way. We multiply this way and integrate this product. I mean, we write here this integral x e to the x dx is equal to x times e to the x u times v, according to this rule. U times v, u is x, v is e to the x, minus the integral of v du, the integral of e to the x du is dx, and then x e to the x minus. Now what is the integral of e to the x? It's just e to the x plus c, because this is indefinite integral, and that's it. This technique is called integration by parts because we divided the integrand into two parts and we dealt with them each part separately. Now let's do another problem. Let's do x natural log x natural log x dx. So in this case we have logarithmic and algebraic. Which one appears first? The logarithmic appears first, so that's u. This is u, and dx with x is dv. So we write them here. U is natural log x, then we find the derivative of this. Derivative of du is 1 over x dx, and then dv is x dx. Then we integrate this to get v equals x squared over 2. Then we multiply this way and we integrate this product, so we get u times v, ln x times x squared over 2, x squared over 2 natural log x, minus the integral of v du. V is x squared over 2 times du is 1 over x dx, and then we simplify here to get x squared over 2 natural log x minus, here this is constant, we can pull it out of the integral of x dx, and then we continue. What is the integral of x? The integral of x is x squared over 2 plus c, and then we simplify more. X squared over 2 natural log x minus 2 times 2 is 4 in the denominator, x squared plus c, and that's it. Now there's another method that's called the tabular method. We make a table and then find the integral. I'm going to do it just for the first problem if you are interested in that method. For example, x e to the x, you make a table. Here the sign is plus minus, plus for multiplication, minus for integration. So this is the integral, and this is the multiplication or derivative, because it comes, actually this is multiplication of the two parts, u times v. Now here we put the derivative and here we put the integral. So we have two parts, x and e to the x, so we can choose d to be x, and since e to the x is easy to integrate, we just use it with the integral. And then for the derivative, we find derivative of x, it's 1. Derivative integral of e to the x is e to the x, and then we continue. So the integral, or the derivative of 1 is 0, and then integral of e to the x is same as e to the x. Now we multiply this way and this way, and since 0 times anything here is just 0, now we add, this is positive sign of the multiplication. We multiply x times e to the x, this is positive, and then negative the integral of this times this, 1 times e to the x, which is e to the x, and then we continue, e to the x minus what is the integral of e to the x, is just e to the x plus c. As you can see, we obtain the same answer. You can use this technique for any problem that is involved in this section. But for me, I usually use the UDV method, this method. And here actually it's not necessary to get 0, but if you get some expression that's easy to integrate, then that's it. Now let's do another problem. If we only have natural log of x dx, what is the integral of this? Now we, as usual, we use u, some part for, we call some part u and the other part is v. Now here we consider that we have 1 dx, so logarithmic is before algebraic, so this is u and this is dv. So u is natural log x, du is 1 over x dx, and dv is dx. That means v is x, the integral of this. And then we multiply this way and then find the integral of that product. So we have x natural log x u times v minus the integral of v times du, v times du. This is x natural log x minus integral of 1 dx. This is x natural log x minus x plus c. One more example. If we have the integral 4e to square root x dx. Now in this case, we don't have e to the x, so what should we do in this case? We have square root x. Now for this problem, we need to apply two techniques: integration by substitution and integration by parts. Let's start with the integration by substitution. We let this power be u because we want to make it easier to integrate or to deal with that function. If we have just e to the x, that's easier to deal with, but if we have e to the square root, it's not easy to deal with that part. So let's use substitution method first. Let u be square root x, then du is, now square root x is x to 1/2. What is derivative of this? It's 1/2 x to 1/2 minus 1, which is negative 1/2 x. We want to find dx. So dx is over 1/2 x to negative 1/2. We can bring this up here. It becomes x to 1/2 du over 1/2. And we flip the denominator. We get 2. X to 1/2 is square root x du. So this is dx. Now we substitute here. We get the integral for e to the u, because square root x is u. Dx is 2 square root x du, but we still have x, but square root x is u. This becomes 4 times 2, which is 8, u square root x times e to u du, and then we write it as 8. We can pull the number out of the integral, u e to the u du. Now this is very similar to which problem? To the first problem that we started with. Instead of x we have u, so the answer should be x e to the x minus e to the x. So this is x e to the x minus e to the x plus c, but x in this case is u because the integral is written in terms of u. And what is u in this case? U is square root x.